Anyway, all right, tomorrow's quiz. It's 4 topics. All right, every problem will fall under one of 4 topics: Hills and SAS, Pythag, 45-45, or 30-60. Real quick review to make sure we're all on the same page. First one, Hills and SAS. You have to have a certain diagram. You can't just go, oh, Hills and SAS, I'll try it out. No, we got to have a right triangle. The original triangle has to be a right one with something placed inside. And what has to be placed inside? An altitude that comes from the right angle drawn to the hypotenuse. That's the only type of diagram. Now look, will it look like that? Maybe not. Maybe it might be rotated. Who knows? But that is the only type of diagram we can use Hills and SAS in. So what I want to do right now, I'm going to go around the room. I'll start with Hills. What does each letter mean? And identify it on my diagram. All right, so what does each letter mean? And then name it on my diagram. So we'll start with H. What's the H stand for? And where is it on my diagram? All right, ready? Let's do this. Good review. 6, let's start. Yep, Thomas, what's the H stand for? Hypotenuse. And yes, when we say hypotenuse in Hills, we are referring to the original, the big right triangle. It's hypotenuse. Good. L in Hills. L, 9, Ian. Leg. Name them both in my diagram.
AB and AB.
Yep. And the question is, hey, which one do I use? Well, it all depends on what the problem says, is what we're looking for and what we're getting. Going back to you, Ian, do I plug in the same leg in Hills or each one?
The same.
Same. Means are the same. I can't stress that enough. Even if you forget, the means here will always be the same. How about that S? What's the S stand for? 3. Here we go, Aiden. Segment. Name one. BC. And the other one's going to be CD. Now, Aiden, going back to you. Let's say I use leg AD in Hills. What segment do I want? Because I can't pick either one.
CD.
Good. The one adjacent. You pick the segment adjacent to the leg you just put in. We're all good? All right. If that doesn't work, it's probably going to be a SAS problem then. We already went through S means segment, but I have a question for Charlie. Charlie, that S, are they the same segments or different? Look where they are. They are. Hey, extremes are different, right? I don't look. Does everyone notice that the Hills and the SAS are the same? The means are always the same. All right, extremes are different. And that A we have not talked about yet. The A in SAS going deep here. You think I know all these by now? Zeev. Altitude. Where is it on the diagram? I haven't labeled it. AC, altitude. Same one or different here in SAS? Same. There's only one. Well, actually, there's a couple altitudes, but the only one we've labeled, and we know the means have to be the same. All right, everyone good with Hills and SAS? Got to be that diagram. Altitude drawn to the hypotenuse. All right, Pythag. Oh, who cares? No, you better care tomorrow. A squared plus B squared, yep, equals C squared, but it's more than that tomorrow, more than that. If I give you 3 side lengths tomorrow of a triangle, 3 side lengths, and you plug the 2 smaller sides in for A and B, and it comes out to be the same as the biggest side squared, that's going to be what type of triangle?
Right.
A right triangle, yeah, that's a right triangle. All right, well, what if they don't come out to be equal? Let's say this scenario happens tomorrow. You square the 2 smaller sides, add them up, and they come out to be bigger than the largest side squared. What type of triangle am I working with now? Go ahead, what do we got? That's an acute triangle. All right, so if C squared comes out to be the smaller value, it's acute, and then obviously we know what's coming up next. If the C squared is actually bigger than the other 2, that's going to be obtuse. I will ask this tomorrow. Okay, I will ask this. And also, any type of problem, don't forget about it. Everyone's always zeroed in. All right, 30, 60, 90, 45, 45, Hill SAS, Hill SAS. If you know 2 sides and you're trying to find the third, it's always an option. Okay, it's always an option. All right, let's go to 45, 45, 90. Let me ask somebody what you know about it. Here you go. This is all I'm going to give you. What do you know about that diagram? All right, what do we know about the diagram? Should be 2 things you can produce from that diagram. Here we go. One thing, Amy.
It's isosceles.
Thanks. How about a little more? What about the sides?
The legs are congruent.
Okay, where are the legs located?
They form the right angle.
Across from the 45s.
Yeah.
Okay, that was brutal getting that out of you. Yep, good, thank you. Legs congruent. We got that now. Other than Pythagorean theorem, how do you find the hypotenuse? Can't use Pythag, just pretend. All right, other than Pythag, going 4, I know there's Doyle.
I will. Times the square root of 2.
What times the square root of
Like
2?
a leg.
Thank you. Times the square root of 2. Everyone's good? Again, hey, you pull a Doyle. We'll call it a Doyle now. You pull a Doyle, and you know the 2 legs, Pythag, right? Pythag, because I'm not letting you look it up tomorrow, right? So if that happens, Pythagorean theorem. All right, and then 30, 60, 90. You should be able to find the longer leg and the hypotenuse in a 30, 60, 90. You tell me which one you want to find first. It's up to you. Your call. Steve, your call. Which one you want to tell me about?
Hypotenuses.
Sure. How do you find the hypotenuse?
Double short leg.
Good. 2 times shorter leg. Where's the shorter leg located? Because I got 2 of them up here. Good. Right? Shorter leg, longer leg, hypotenuse. How do I find the longer leg now? A couple more here. How do I find the longer leg here? Just call Doyle. Come on.
The shorter leg, 1.5.
1.5?
He said radical.
Oh, radical 3. It's like 1.5. Yeah. Shorter leg times radical 3. Good. Now, notice I don't have a rule for the shorter leg, how to find the shorter leg. I'll probably either give you the longer leg or the hypotenuse. Now solve for the shorter leg. Okay, I don't need to give you a third rule. All right, just plug in what you have, substitute in, and solve for the shorter leg. Any questions before the reminders are probably the most important part, I think. All right, reminders. Let's say, and I'm never going to give you something this easy tomorrow, but let's say this is 8 radical 3, and I'm trying to find the hypotenuse. All right? All right, first thing is, do I know if this is 45, 45, or 30, 60? No, so don't make it into it. All right? Unless you are mathematically positive that it's a 45, 45, or 30, 60, do not write in the angles. Oh, they look congruent. I'm going to put a 45. No, stop. All right, stop. Unless you mathematically can prove to yourself that those are 45, 45, or 30, 60, do not write in angle measurements that aren't there for you. Next thing, we got to use Pythag here. Hopefully we realize that. 8 squared plus, here's what I want to remind you about. What are you going to plug in your calculator next? Parentheses. Because if we do this in the calculator's just going to think you're squaring radical 3, but we need to square the whole side. All right, so please keep that in mind. Also tomorrow, it's been a while, and I don't know how many of you look at your notes at all to review. What happens if I pull this on you tomorrow? I'm just making this up. All right, solve for x. So we have what? X squared plus x minus 2 squared equals 16. Are we going to be able to handle that correctly tomorrow? We're not pulling this, are we? All right, I don't know how we got through algebra 1. All right, we're going to do x minus 2 times itself to handle that. We're all good. Ready? I'm telling you that because prepare for it. Prepare for that tomorrow, somewhere on the quiz. I got more reminders. Let's say you have to round your answer to the nearest 10th, 100th, whole number. When do you round? At the end of the problem. All right, we round at the end of the problem. Not midway. You write out the full decimal on your calculator. Round at the end. And I probably shouldn't be telling you this last reminder now that we're in the second semester, but anything going forward, don't be surprised if you have to factor. Okay, don't be surprised if you have to factor tomorrow. All right? And that's just I'm not going to remind you again all year, but anything going forward here, you may have to factor. including tomorrow's quiz. So don't be surprised. Good? And then, reject a negative answer because it gives you a negative side length. That's all fair game. All right, all fair game. Anything else? We're good? All right, so let's go to real quick. Go ahead, go to your packet now, day 6. Do not start any problems, please. I want to review where you can practice from. All right, one place to practice from is right there, day 6. The answer key is in the next couple pages, so you don't have to go on Classroom. Everyone see the textbook questions at the top I'm suggesting. There's place number 2 to practice. And a third place, which I rarely do for a quiz, but this is the first one of the third quarter, and I do not want you to dig yourself a hole. Up on Classroom under Unit 8, I have this one little thing here called Extra Review for Quiz 1. This thing is a beast. You want some Hill SAS practice? It's right here. All right, Hill SAS. Oh, I know you might be good at Hill SAS, but maybe not at 30-60, 45-45 triangles. You want to get some practice there? Oh, maybe you're good so far, but none of us. Ooh, the double triangle ones right on top of each other. I don't know how smooth we are with those. All right, so it's got all those practice problems right up on Classroom if you need somewhere extra to review. I am not going to go over any of those problems with you. You can work on it with anybody you'd like, but please check your answers in the back